This is a neat book called Patterns by Sarah Pistoia. And in nature, there are so many different patterns of color and patterns of number. So let's take a look and see what patterns we find. We use patterns to recognize all kinds of things in our world. Colors or shapes used over and over form a pattern. You can see patterns on wrapping paper. You can see patterns on leaves and flowers. These patterns are on animal fur. Guess which animals these are? The world would be different without patterns, without stripes. This zebra would look like a horse. Tigers and leopards are both wildcats. Is this a tiger or a leopard? You can tell by the stripes on its fur. Tigers have stripes, leopards have spots. Patterns can be made with shapes, sizes, colors, and positions. Look at the animal on the next page. You know it's a panda because it looks like a panda. But what makes a panda look different from a grizzly bear? A panda's black and white coloring forms a pattern, and that pattern makes the panda look very different from other animals. Pandas have white faces with black patches around their ears. Where else do you see the black patches on the panda? Sometimes the parts of a pattern repeat themselves. When patterns repeat, it helps us think about what might come next. Like 2 red, 1 yellow, 1 row of green, 2 rows of red, 1 yellow, 1 row of green, 2 rows of red. So what do you think would come next? These jelly beans form a pattern, and this pattern uses colors and numbers. How can you tell what color comes next? To figure out what color comes next, think about the order of the colors you see, and next count how many of each color there are. Red, red, yellow, green, red, red, yellow, green. Some patterns are simple, like the stripes on this snake. Do you see the pattern? Red, black, yellow, black, red, black, yellow, black. Some patterns aren't so simple, and this wrapping paper has a pattern, but it keeps changing. Can you tell what might come next? It's hard to know what would come next in this pattern. Knowing about patterns can help us in math class. You already know some patterns in math. When you count, you use a pattern. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. What comes next? Did you say 10? You're right. What happens when you reach 10? Well, the pattern starts all over again, but this time we put a 1 in front of each number. 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Do you see the pattern? Now try counting the peanuts on the next page. What happens when we reach 19? We start the pattern all over again at 20. Can you think of the last 4 numbers in this pattern? What comes after 6? What comes after 16? Now think about what comes after 26. The last 4 numbers are 27, 28, 29, and 30. Did the pattern change? Yes. We used the number 3 and started the patterns all over again. Something doesn't sound quite right about that. I think it should read, we used the number 2 and started the pattern all over again with 27, 28, 29, and then we get to the 3. The days of the week form a pattern too. What day always comes after Sunday? Which day always comes after Wednesday? See, we have Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. Knowing the days of the week can help you solve this math problem. Let's say you leave home on Saturday. To go to your grandma's house, it will take 4 days to get there. On what day will you arrive? Saturday, Sunday, Monday, Tuesday. You'll be there Tuesday. Look at the hundreds chart on the next page. Do you see the patterns that help you with math? Count the numbers with yellow jelly beans. You are counting by fives. What about the last row? Do you know where to place the jelly beans to finish the pattern? The yellow jelly bean numbers on this chart make a pattern that count by fives. Study the pattern. The numbers in the last row must be 95 and 100. 5, 10, 15, 20, 25, 30, 35, 40. We go 45, 50, 55, 60, 65, 70, 75, 80, 85, 90. And then we have 95 and 100. And an easy way to remember how to count by fives is your numbers are either going to end in a 5 or they end in a 0. It's sneaky that way, you know. Now, let's see. That is a long, big chart. But I know in first grade we're going to have to know our numbers by 2s and 5s through 120. I should say we should be able to skip count by 2s and 5s and 10s through 120. This musician thinks about patterns when he plays or writes music. Scientists think about finding patterns when they study plants. Artists think about patterns when they create a work of art. Patterns of letters help you learn to read. Discovering and using patterns is important in math too. You start thinking about patterns, you see them everywhere. And the final pattern that we see here is one known as Fibonacci's pattern. And it's a number pattern of 1, 1, 3, 5, 8, and 13. And that pattern is present in shells like this, or if you look on the bottom of a pine cone. There are shapes and patterns absolutely everywhere you look. The end.